Okay, 4.2, this is straight line motion. So a lot of the times they'll be talking about a particle moving in a straight line, or say a bug walking on a line. So this will be your number line. Let's say this is your particle, and it's going to be moving back and forth according to this function. This is S of t means the position of the particle. So if we plugged in the position at time t equals 1, so that could be 1 second, 1 year. In this case, it doesn't say, it doesn't matter, it just says at t equals 3. So we don't have to deal with seconds or years. But we know that whenever we plug something into this function, a value of t, we're going to output the position of the particle. So let's say this was -1, and we're talking about time t equals 3 or 4, then S of 4 is going to be -1, because that's the position at that point. But we're also going to be asked for the velocity or the acceleration. So the position, or the derivative of the position, is equal to the velocity. So that makes sense. If you're moving in a car, your speed or your velocity, that's given by how fast your position is changing. So, and then similarly, the derivative of the velocity, v prime of t, is equal to the acceleration of the particle. So you're going to be tested on these in the AP exam. They're going to want to see if you know the relationship between position, velocity, and acceleration. So it's important to know this relationship here. So let's look at the problem. A particle moves along a straight line. Its position can be modeled by this function. For t is greater than or equal to 0. We're only concerned with t equals 3 here, so we don't have to worry about that. And we're looking for the particle's acceleration at t equals 3. So if you remember what we did in higher order derivatives, we know that acceleration is the derivative of velocity, and velocity is the derivative of position. So we know that acceleration is going to be equal to the second derivative of position. So we know that based on this position function, we can find the acceleration at a point just by taking two derivatives here. So using the power rule, we have 3t squared minus 4t plus 5. And that is v of t. And now we need to take another derivative because we're looking for the acceleration. So now we do with the power rule again, 6t minus 4 equals a of t. And now to find the particle's acceleration at t equals 3, right here, we just plug in 3 to this t right here. So we have 6 times 3 minus 4 is equal to a of 3. So that equals 18 minus 4, which equals 14. And that's one of our answer choices. So if we click on it, it's correct. And that's pretty much straight line motion. It'll ask you what's the velocity or acceleration of a particle at a point based on a function. And sometimes you'll need to find out at what time does the particle change direction, but that's in the next part. So another question is the position of an object moving along a horizontal line, and you want to find the intervals where this is speeding up. So the way to do this, we're going to have to use something called critical points. So critical point, critical point is just going to be any time where the derivative f prime of x, it could be f, it could be g, it doesn't matter, just some function, or f prime of C, because we're not talking about generally. So C is just a replacement for any number. We could choose any point. We're just looking for a place where the derivative at that point is either equal to 0, undefined, yeah, I believe it's just 0 and undefined. So that could be, undefined could just be when it's something over 0. It could, graphically, it could look like an absolute value function. Remember that the derivative right here is still equal to, is still undefined. So that can be considered a critical point. So to find the intervals where something is speeding up, we're gonna have to use these critical points. So to find if the speed is positive or the velocity is positive or negative, so if it's going forwards or backwards, we're gonna have to take the derivative of this to find the velocity function. So using the power rule, we have v of t equals t squared minus 6t plus 8. I'll erase this. So we want to find where this, since there's no denominator, it's not a fraction, this can't be undefined, so we're just looking for where this equals 0. So we can factor this as t minus 2 and t minus 4 equals 0. And we know we have zeros at t equals 2 and t equals 4. So now to find, oh, and the next step, now that we have these zeros of the velocity function, we're trying to find out where it's speeding up. So that sounds a lot like acceleration. That's the definition of acceleration, except this is a little different. We're not just looking to see if the acceleration is positive, to see if it's accelerating forwards, because if you're in a car and you're going backwards and you start going backwards more quickly, that would technically be negative acceleration, but the car is still speeding up. You see it going faster, just in the negative direction. So we're gonna have to look for times where the signs of v of t and a of t are the same. So v of t and a of t, same sign. So that could be positive and positive or negative and negative. Because if you're moving forward and your acceleration is positive, you're moving forward more quickly, then you're speeding up. And if you're going backwards, the velocity is negative, and your velocity is getting more and more negative, then you're still speeding up. So to find out what points that they have the same sign, we also have to look at the acceleration function. So the acceleration is just the derivative of this v right here. So we can use the power rule. 2t minus 6 equals 0, which equals 2 times t minus 3. T equals 3 is 0. So let me clean this up a little bit. Still not that clean, but we can work with it. So we know that when something equals 0, it's changing sign at that point for these simple polynomial functions. If you look here, if you plug in, let's say 0, which is less than the 0, 3, we have 2 times 0 minus 3, which is negative 3 times 2, which is negative 6. So we know that when the time is less than 3, the acceleration is going to be negative. So a of t is less than 0 for x, or for t is less than 3. Okay, so that tells us when the acceleration is negative. And then vice versa is true. The acceleration is positive when t is greater than 0. So we're going to look for the times where the velocity sign and the acceleration sign are the same. So if we look here, and the first thing you do is plug in a point to just see if the velocity is negative on that interval or positive. So here, if we plug in 0, which is less than 2, we have 0, we have 0 minus 2, negative 2, times 0 minus 4, negative 2 times negative 4. We have that the acceleration, the velocity is positive. So v of t is positive when t is less than 2. Okay, so if it's positive when it's less than 2, 2 is less than 3. So every time the velocity is positive on this interval, the acceleration is going to be negative. So we know that t is less than 2 is not going to work. You know that t is less than 2 is not going to work for our purposes because we're looking for the times where the acceleration and the velocity have the same sign. So here it's positive and the acceleration is negative, so that doesn't work. So now I'll open a whiteboard. So what was it? We had v of t equals t minus 2 times t minus 4. And then a of t equals 2t minus 3. So we know that t is less than 2 is not going to work because v of t is positive, a of t is negative. So now let's check in between 2 and 3, because that's where the velocity or the acceleration are not going to change on that interval. So we're just looking to see if it works there. So if we plug in, let's say 2.5, we have 2.5 minus 2, which is 0.5 times 2.5 minus 4, which is negative 1.5. Then we have a negative number equals negative. We don't care what that negative number is, we just care that it's negative. So now let's look at our acceleration function. So we have 2 times 2.5 minus 3, which is negative 0.5. Negative 0.5 times 2 is negative. Negative times a positive equals negative. So we know that when t is between 2 and 3, the velocity is negative and the acceleration is negative. So this works. We're going to want to circle this to come back to in our answer. And then now let's check between 3 and 4, because the acceleration changes signs at t equals 3, but the velocity function does not. So let's see what happens here. So if we plug in something like 3.5 to both of these functions, we have, I'll erase this. If we plug in 3.5, we have 3.5 minus 2, 1.5 times 3.5 minus 4, negative 0.5, negative times a positive equals negative something. we don't care what it is. And now if we look at acceleration, we have 2 times 3.5 minus 3. 0.5 times 2 is positive. Positive and negative, that does not work. So when t is between 3 and 4, the velocity is negative and the acceleration is positive. So we know that this does not work. Okay, and our last interval that we can check is when t is greater than 4. So let's try 5. We don't have to do a fraction because we're not doing between 2 points. We don't need to do 2.5 just because, or 4.5 just because we're not bounded by another number. So if we plug in 5 minus 2 times 5 minus 4, these are both positive. So that's going to be a positive. And if we plug in 5 to the acceleration, 2 times 5 minus 3, it's going to be positive. So we know that between 4 and infinity, they're both going to be positive. It's positive, and a of t, it's also positive. So that works. So these are our two answers right here. So now let's go back and see if that matches up with any of our answer choices. So between 2 and 3 and 4 and infinity, that looks right. And it is. So that's how you do those. Those take a little bit more work. You don't always have to calculate explicitly what the acceleration is or what the velocity is, as long as you know the sign is positive or negative. So those can be a little time consuming, but just remember, you can always take up less time if you think of it as positive and negative.